Welcome to Windows Containers on AWS Ninja Bootcamp. Containers have taken DevOps companies by storm, and more companies are adopting containers to increase agility, speed, and innovation. In this lab series, we are going to master the art of running Windows containers on AWS. You will learn container concepts and will get your hands dirty by executing labs tailor-made to bring your container knowledge to that of a container master. For those who are new to container world, don't worry. We will first learn container basics, then we'll move into executing your containers on AWS, and finally explore more advanced container concepts like automated container deployments. In this short introduction, we will go through some Windows use cases, and then learn few container concepts, and then compare containers to virtual machines. Finally, we will understand and learn different ways that you can run Windows containers. So, let's get started. What are the use cases to run Windows containers? Before understanding use cases, we need to understand the evolution of containers. Back in the days, about 20 years ago, we used to run physical servers. The challenge of running physical servers is that you need to buy them, bring them into your company, rack them up, wire them up, and it takes ages to provision these servers. So the business lost their agility. But with the introduction of virtual machines, some of the limitations of the physical machines or the physical servers were avoided. But the virtual machines itself had some limitations. You need to have a separate operating system for each virtual machines, and some of the resources are wasted. And that's why the concepts of containers came into the world. So we can think containers as the natural progression of virtual machines. Virtual machines abstract the physical hardware, whereas the containers abstract the operating systems. We are all familiar with this kind of a server utilization graph. Most of our servers are not utilized a lot. Sometimes they are utilized about 20%. At peak, they may reach to about 40%. Is this the best way to use your servers? So the virtualization addressed some of these problems and what they allowed you to do to increase the server utilization. In AWS environment, think that you are running some Windows instances. So in this case, I'm running an M5 4X large instance, which cost me about $1.5 here in Sydney at the time of recording. But imagine that the server utilization in my case is about 15%. Of course, it's not a well-utilized server. But just by changing the instance size from M5 4X large to M5X large, I increased the server utilization to about 60%. And also let some headroom in case there's a spiky workload, but immediately I save about 75%. So this is one way to increase server utilization. The other way to increase server utilization is through containerization, where you pack a lot of application into a single host and then increase the packing density and increase the server utilization. Another use case comes into picture when you try to go for a capacity reservation. If you run 6 M5 4X large instances in Sydney, at the time of this recording, it cost about $7,500 if you use on-demand instances. But one way to save cost is to go for capacity reservation, where you go for 3-year all upfront reservation, which will cost you about $5,000 and gives you about 33% savings. Great. Another way to save cost is to bring your own licenses. So you have these 3 reservations. So instead of that, you bring your own licenses for Windows Server, use a dedicated host, and the cost goes to about $2,000 per month. The challenge the customer face in this kind of situation is, hey, I'm now reserving the capacity of AWS, but I'm not sure whether I'm going to use them. But if you have the confidence that, hey, I'm going to have workloads, or I'm going to pack as many applications as possible on these servers that I have reserved, then I can really derive the value of going for this capacity reservation or bringing your own license and going for a dedicated host that has a lot of slots available for you to spin up virtual machines. What are the other ways that you can increase the server utilization? Imagine that we are running 4 M5 large web applications, each 50% utilized. Also think that we are running a 25% utilized database instance running M5 4X large instance. And this cost about $1,900 at the time of recording in Sydney region. One way to increase the server utilization is to run this application in one M5 4x large instance. You run your web application and database in single instance and increase the server utilization to about 50%. You immediately save about 37% by doing this kind of a design. But the challenge here is that you have these web applications which are not properly isolated. This may be a finance application that has to run in isolation to the HR application. The database administrator may not be happy because he cannot patch this database without affecting the web application. But if we can find some way to isolate these environments, this kind of a setup would still work. We'll also ask, how about the high availability? So if this environment is highly available, very likely you will run two of these kind of designs in two availability zones. Of course, this also you can run in two availability zones if you want. So one instance, one such configuration in one availability zone, another configuration like this in another availability zone. So here the real challenge is not about making it highly available, but the challenge here is how to get the isolation. So the containers provide some ways to isolate these kind of environments very easily. What are the kind of applications you can containerize and run on Windows containers? The very famous ones are IIS-based applications like ASP.NET, MVC applications, Web API applications, or traditional web services. You can also run batch applications like console applications, SSIS packages, PowerShell script, command line interfaces, and a lot of batch applications that you use to integrate enterprise systems can be containerized and run on Windows containers. You can also run Windows services like SQL Server, MySQL, Node, to give a few examples. There are a plethora of applications you can run on Windows containers. However, you cannot run Windows Forms application that demands a graphical user interface. So other than that, most of the applications that you use in traditional web development in your database systems can be containerized. Let's learn few container concepts. To begin with, we'll compare virtual machines to containers. Both need to have some kind of a physical server to run. Both need a host operating system. In the case of virtual machines, you have this concept called hypervisor, which abstracts the hardware. And on top of the hypervisor, you start virtual machines. So in this case, I have started two virtual machines. The challenge with the virtual machines is that some shareable resources are not shared well. Imagine that these two virtual machines are running Windows 2012 operating system. Very likely 99% of the time, the content of the operating system, and let's say its patched version, are going to be the same. So if this operating system takes 40 GB of storage, you are going to have the same content again on virtual machine 2, and it wastes the hardware available for the applications. And also this operating system spin up their own background task, which takes up the CPU and memory, which the applications can use. In the case of containers, what you have is this concept called immutable images. So I have two images. One, let's say OS 1 is Windows Server Core image and OS 2 is Windows Nano Server. And on top of that, let's say you install some frameworks. You have now containers that use this base operating system and then run. They still have the isolation. Container 1 has its own file space, it has its own registry, it has its own process structure, memory structure. And if you install something on container 1, it does not affect container 2. Container 2 processors cannot affect the processors running on container 1. So you still have the isolation, but some content are shared across the container host. So for example, you don't need to go through a very complex boot process like the virtual machines has to do, because the container host that these containers are running has already boot up. So these containers can start up very quickly. They don't need to start a lot of background tasks. For example, they don't need to run virus scanners on inside them. So that's why the containers are very lightweight and can start fast compared to virtual machines. Effectively, what we have done is increased in the packing density of the applications. So in the case of VMs, we ran only 2 applications, but in the case of containers, we now run 6 applications and increase the packing density of the applications on a given hardware. There are other advantages to containerize your applications. Docker has this concept called images and layers. Let's say you want to run 2 applications, application 1 and application 2. You base out this application, let's say a base operating system image running on layer 1, let's say Windows Server Core image. Let's say you patch this layer with some security updates from Microsoft. If application 1 is, let's say, a .NET application, you can install .NET framework on top of layer 2, and then you install the application on layer 4. Application 2 may not need .NET framework, so it may be a Java application, so it can use the patch version, install the Java framework on layer 3, and then finally install application 2 on layer 4. So Docker has this concept of shared layers, so which means that content on layer 1 and layer 2 are shared across application 1 and application 2. This has multiple advantages, especially, for example, when you try to pull an image, you are not going to download images that already exist. And also it makes your life easy when you are going to do continuous deliveries, because existing layers are not downloaded, so you can easily build and publish your application without taking ages as of copying virtual machines. Patching and maintenance is also easy. Imagine that I have an application called application 1 and application 2. They are all ASP.NET application that depends on the ASP.NET latest version of Docker image. So time comes when this latest image has to be patched. So instead of running the version 10, now you want to run version, let's say 20, and you update it because your application are pointing into the latest version of the image. They will still function. Of course, you need to test the application after patching to any incompatibilities, but updating them is not that difficult. Same for Windows Server. Let's say instead of running version 200, I'm going to upgrade it into another version, the latest version from Microsoft Patch, running version 300. ASP.NET layer depends on the Windows Server latest image, so when you build this application, it still will function. Still, you need to test the application, but the patching and maintenance is super easy with Windows containers. What are the components involved in a containerized environment? You need to have an operating system. In the case of Microsoft World, it's going to be Windows 2016 Server with container support, and we call it the container host. In this container host, you will have the Docker engine installed. It's running as a Windows service, and we usually call this one the Docker engine or Docker daemon or Docker service. It exposes commands like to inspect the containers, to get the list of containers running, to check what kind of images are available. And of course, you can execute some commands, give some commands to the Docker engine, and it can spin up containers. You interact with the Docker engine with a Docker client, and it's going to be an exe application called Docker exe. And every time when you run Docker commands, like for example, Docker run, those commands are executed against the Docker engine, and the Docker engine responds for them. Don't worry about what this Docker run is. We will learn all the Docker commands in subsequent labs. There are two ways that you can run Windows containers. One is the native Docker containers on Windows, as I have given on this side. The other way is to run Hyper-V based containers. If you want to run a Linux operating system, or let's say you want to run a Linux container, your only option is to use Hyper-V based containers. And there are some rare occasions where you want to run, let's say, a very security controlled environment where you need to have a virtualized environment or virtual machine for your application. In this case, Hyper-V based containers will be an option. Of course, to run Hyper-V based containers, you need to have hypervisor installed. And in most cases, AWS, you don't write nested hypervisor. And unless you use our bare metal instances, you are not going to use Hyper-V on top of AWS virtualization, because we don't expose virtualization instruction for the normal instances like on-demand instances that we are allowing you to run. So in this lab session, we are going to explore only Windows containers, which is the most cases for Windows-based applications. In the subsequent labs, we will get our hands dirty and then learn about Docker and Windows containers on AWS.